Next up, Jason and Chris are going to talk to us about Azure Arc. So, welcome, gentlemen.
Hello. How's it going, Brian? Can you hear me?
I can hear you.
Perfect. Hey, everybody. I'm Jason Hansen, and I'm joined by Chris Sanders. We're both PMs on the Azure Arc team. And the plan for this session, I'm going to give a little bit of an overview around what Azure Arc is, what we're doing, why we're doing it, and some of the scenarios that we've implemented, as well as talk about some of the most recent announcements and previews that we have up and running with links for you to be able to kick the tires on that. And then we'll pass it over to Chris, who's going to demo some new scenarios that we have around GitOps and GitOps across Arc and AKS.
Great. Looking forward to it. We'll see you at the other side.
All right. Let's go ahead and get stuck in. So as I mentioned, my name is Jason Hansen. I'm a PM on the Arc team. And again, just want to set some context around what Azure Arc is and why we're doing what we're doing. And really, this comes from our customers' experience that their environments and their needs of their applications are continuing to evolve. And that evolution is happening across a number of different vectors. First is the sheer number of applications that our customers are running across a number of different form factors. So they could be doing some new stuff in containers on top of Kubernetes, maybe writing some serverless applications. We're still, dealing with a large number of, say, line of business apps that are running in virtual machines, and again, across a number of languages and runtimes. Now, increasingly, those applications need to run across lots of diverse infrastructure. And so that could be, your existing investments in data centers. That could be hosting providers that you have, MSPs or CSPs that are running your infrastructure for you. Or commonly, we need to run a lot of applications close to, a specific location. Now, in manufacturing, that could be a factory floor or a typical office location. Again, lots of apps, lots of different locations. And increasingly, we also see customers that are adopting or embracing a multi-cloud disposition. And this could be either because you need a specific capability from one of the cloud providers, or you need to get your applications closer to a specific set of customers serviced by a particular cloud, or you're just looking for a business continuity and disaster recovery standpoint, set of scenarios. Now, across the board, with all of these various moving pieces across all of this infrastructure, the question for our customers is, how do we govern and operate across these disparate environments? How do we ensure that security is enforced across the entire organization? And at the same time, how do I make sure that my developers remain agile? Now, the Azure perspective here is that Azure Arc is going to help us attach Azure Management Services and our Azure-based control plane to these various infrastructures running in lots of different locations. And so all up, we see the Azure platform as being purpose-built for a hybrid set of scenarios. And Azure Arc helps us manage and operate your infrastructure from that Azure control plane, and additionally runs Azure services on your infrastructure as we start to bring Azure services downward. So this really there's two streams within this flow. The first is Azure Arc enabled infrastructure. And this is all about attaching servers and Kubernetes clusters that you have running in lots of different locations or on other cloud providers into Azure. And then once that infrastructure is attached, we can start to bring Azure Arc enabled services down into your environment, really giving you kind of the attached resources and then bring management services down. Now let's go ahead and look at, from a high level architecture, what this looks like. Now, this is the Azure platform. On the left, we have Azure customers that use tools and experiences like the CLI, the portal, all the Azure APIs. Those tools and experiences interface with this control layer, and this is the control plane. Now, we call this the Azure Resource Manager, and Azure Resource Manager sits on top of and governs resources. Now, resources are anything inside Azure. It can be a virtual machine, it can be a Kubernetes cluster, it could be a database, it could be HD Insights, Azure Container Instance, a container registry. These are all resources. And the Azure Resource Manager uses that resource interface to be able to list those resources consistently, apply role-based access control, apply tags, and place those resources in Azure subscriptions or Azure resource groups. And again, no matter what that resource type is, if we add or remove resources to the Azure platform, that Azure Resource Manager provides a consistent experience for that. And today, again, those resources are running in Azure regions. Now, if we look at the very top box in develop and operate, we have a set of Azure-based management services. So this is services like Azure Sentinel, Azure Security Center, Azure Monitor, Azure Backup. These services govern or provide additional capabilities across a set of services. And the reason that resources. And the reason that they're able to do that is, again, this control plane layer, where all of the access to these resources are governed by Azure Resource Manager. So again, as we add additional resource types, those Azure-based management services can wrap their arms around it. Now, how Azure Arc fits into this picture is like, here, Azure Arc builds a set of connective tissue to bring resources that aren't running in Azure regions. So again, running on a different cloud provider, running in a data center, running in a remote office, branch office, exposing that infrastructure into the control plane layer. Now, once we've done that, again, these develop and operate services up on the very top box can now start to wrap their arms around that Arc-enabled infrastructure. So what kind of infrastructure types do we support today? So we have three that are out in preview. We have three that are implemented. The first is Azure Arc enabled servers. And this is a GA offering. And this allows you to attach any server. It could be bare metal, it could be a virtual machine, it could be Windows or Linux, attach that server into Azure. Once you do that, by deploying the Azure Arc machine agent, you can see your Azure-based virtual machines and the servers and virtual machines that are running in your own data centers side by side. And again, consistency is key here. I can see everything in the portal. I can use Azure Role-Based Access Control to govern who can and can't see those particular servers. And then again, bring to bear some of those Azure management services. Now, the second offering that we have is Azure Arc enabled SQL Server. And this is much like Azure Arc enabled servers, but it's purpose-built for SQL servers. Again, organization, inventory, and monitoring are all Azure consistent. With extensions into the SQL Server running it on that box. So that again brings best practices and analysis into the Azure portal. It brings monitoring so that again you have a consistent experience running on Azure as well as your SQL servers on-prem. Last but not least is Azure Arc enabled Kubernetes. By attaching a Kubernetes cluster running on your own infrastructure or running on another cloud provider, you can see your Arc-enabled Kubernetes clusters side by side with your AKS clusters. Again, tagging, grouping, role-based access control are all consistent. So single pane of glass for your entire portfolio, no matter where those resources happen to be running. Now, additionally, in terms of those services that we can bring to bear, Azure Monitor for containers, Azure Policy for Kubernetes, and our GitOps configuration management service can now start to run consistently across both of those form factors. Now, in terms of support for Kubernetes clusters, our MO here is bring us a CNCF conformant Kubernetes cluster, and you should be able to deploy and run the Azure Arc operators or agents in that Kubernetes cluster. Now, we've also worked closely with some distribution providers in the space, which includes Canonical Charmed Kubernetes, Red Hat OpenShift, and Rancher environment to make sure that the Azure Arc agents work well on their kube distros, and that we have some mutual testing and validation back and forth. As well, so from a first-party standpoint, we have a number of offerings like AKS and Azure Stack HCI, which you'll hear a little bit more about later today, as well as Azure Stack Edge, where we've baked in the Arc agents by default. So again, you get that consistent experience for portal, for GitOps, for monitoring, and policy. Now, I want to talk a little bit about some of the scenarios. We've covered some of these and want to just poke in a little bit. So for Azure Arc enabled servers, really it's all about reach. So again, Linux and Windows, virtual machines, and bare metal. And again, if you can deploy an agent to that machine and that agent has line of sight to the Azure platform, you'll see that resource pop up in the Azure portal. And from there, you'll be able to, again, start to manage it. Now, one thing for Windows folks, this is a domain agnostic management. So if you have Windows servers or Windows servers that are not domain joined, you can deploy the agent, you can bring them up in Azure and start to manage them using Azure Policy, which is a pretty powerful scenario. In terms of organization and inventory, again, all of the abstractions that you have on the Azure platform are available to you. So where we talk about subscriptions, management groups, resource groups, all of those work seamlessly with Arc-enabled servers. And additionally, if you're doing management on behalf of where you're managing a subscription, you can use tools like Azure Lighthouse. Again, this demonstrates the power of integrating with the Azure Resource Manager, and that control plane gives us a broad set of flexibility in terms of what management services we can bring down to our infrastructure. Next, to talk a little bit more about governance and security. One of the nice things that now that you see these resources surfaced in Azure Resource Manager, we can use Azure Policy to govern these resources. And some of the things, if you're not familiar with Azure Policy, this allows you to make statements about your infrastructure. For example, I want to ensure that any server that is attached to the specific subscription has a secure password, or I want to audit certificates that are running on machines and surface a warning or alert if a certificate is going to expire in 45 days. Those policies can be described in Azure and applied to various scopes, which again gives you a lot of management control and flexibility about the resources that are attached to your Azure infrastructure. And last but not least, role-based access control, which allows you to say, describe who can and can't see a particular resource, which allows you to say, central IT can see all of the servers that are attached to my Azure infrastructure, but only specific workload owners or application teams can see a specific set of resource groups. Now, again, some of those services that I haven't called out before that are lit up by Arc enabling your infrastructure: Azure Policy, Defender, Sentinel, Azure Monitor, change in inventory tracking. Again, the power of Azure Arc here is that as Azure continues to make investments in our cloud-based management services, those services can be broadly applied within your organization. All right, let's talk a little bit more about Arc-enabled Kubernetes. We've talked about Connect. So again, any CNCF conformant Kubernetes, as long as it can run our container workloads, will be able to be registered with a portal. Configuration, which Chris will cover, all around GitOps. Operation and monitoring, Azure Monitor for container integration, observability into the dashboard, and again, consistent role-based access control, not only for the cluster itself, but be baked into use Azure Active Directory to govern access to resources. All right, so we've talked a little bit about infrastructure, and just one thing that I want to highlight, we talked about Azure Arc-enabled services, and one of the premier services that we have in the Azure Arc family today is Azure Arc-enabled data services. And what this does is it brings the Azure SQL managed instance capability that you have on Azure infrastructure today and starts to run that in your own environment. So for example, if you have data governance requirements, or you've got sovereignty requirements, or just latency requirements, but want the benefit and capability of a managed database as a service for you, you can now start to run that in your own environment. Again, this stands up and deploys into any Kubernetes cluster. And if that's Arc enabled, we again have that consistency across the board. So that's a quick overview. I want to go ahead and tee it up now for Chris to go ahead and dig in and do a deep dive. Actually, I missed a slide. I got to talk about the most recent updates. I'll tee it up for Chris. Apologize. So new updates, Azure Arc enabled servers. We've got alerts for Azure Arc. So you can define an alert on your servers. We have an Azure Key Vault extension, which allows you to attach or grant access from a server up to Azure Arc, to Azure Key Vault for fetching and keeping certificates up to date. We also have the vulnerability assessment across your servers, which is now available in public preview. In private preview, we're working toward deploying the next version of the Azure Monitoring Agent for folks who have been following that on Azure. Now, coming soon, we have private link support. So this allows you to attach your servers on-prem to a private endpoint so that there's no direct internet access required, as well as support for Windows Server 2008. Now, if you're interested in any of those previews, I've got some aka.ms links for you to be able to sign up and access the private previews. Now, on the Kubernetes side, we've got a few things in public preview. We recently added outbound proxy support. So if your clusters need to go to Azure through a public proxy, that scenario is now supported. And all of our agent container images are now fetched from Microsoft Container Registry. In terms of private preview, we've got a few things that we built and we're testing out with customers. First is cluster extensions, which again gives you a unified interface for installing offerings like Azure Monitor for containers or Azure Policy. We have Cluster Connect feature, which allows you to use a cloud-hosted endpoint to be able to interact with any cluster running on your infrastructure using standard Kubernetes tools. And then the scenarios that Sean showed earlier in terms of AAD-based authentication and authorization for resources, we have a private preview up and running for non-AKS clusters. And then last but not least, which is what I was teeing up before, GitOps for Arc and AKS clusters. So with that, I'm going to go ahead and hand it off to go ahead and get away for the GitOps demo.
Hey, Jason, before we get going with Chris, we do have a question from the audience. Garish is asking, can we upgrade a set of Kubernetes clusters in Arc all at once? And if you're going to cover this later with Chris's demo, that's fine, but just a quick question.
Yeah, I'll just tackle that at a high level. So right now with GitOps, if you can check in a resource into a Git repository, we can apply that to one or more Kubernetes clusters. What we don't support today is cluster lifecycle management outside of that GitOps scenario. It is something that we are definitely evaluating and working on. And if you are interested in what that might look like, please reach out to me. I'd be happy to talk to you about your requirements for cluster lifecycle management in more detail.
Awesome. Thank you, Jason.
Hey, folks. Chris Sanders here. And I'm going to be showing you a demo on GitOps after Jason just explained to you quite a bit about Azure Arc-enabled Kubernetes. I'm Chris Sanders, and I'm a program manager, and I work on Azure Arc. And what I'd like to do is level set before I get into the demo, level set about Azure Arc-enabled Kubernetes. And the value prop it brings is basically when you connect your Kubernetes clusters, which are located anywhere, they can be on-prem, they can be in another cloud, they can be in Azure, you connect them up to Azure, so you can see them all in one pane of glass. Then you can configure those clusters, apply your Kubernetes configurations, apply your applications from your Git repo, and that's what I'm going to demo today. You can also monitor all of your Kubernetes clusters from a single pane of glass using Azure Monitor, and you can govern and secure all your clusters using Azure Policy, again, from a single pane of glass within Azure. And again, you can do this from any infrastructure, CNCF compliant Kubernetes, and any of the cloud providers as well. So let's talk a little bit about what GitOps is. Again, just to level set. GitOps is a process of managing your Kubernetes clusters using your Git repo as the source of truth for your Kubernetes clusters. And what this means is that you're going to use your Git repo as a single place where you operate against your Kubernetes clusters. That means all of the Kubernetes objects and applications that you're going to deploy are going to be created, changed, and deleted starting in your Git repo. These changes are written into declarative files, YAML files, that you store within your Git repo. And because they're stored in a Git repo, of course, you can view them anytime you want because these are flat files that you can see exactly what's in them. They are version controlled in this source control system, so you can always see what changed from one version to the next. And when you do commit to your Git repo with a new change into one of your Kubernetes manifests or a new application update, then that will go through your change review process. And when your commit is approved and is actually merged into the repo, then an operator that's on the Kubernetes clusters that is tracking that Git repo will pull down the changes and apply them to the cluster. That operator that's on the cluster is also a desired state configuration operator. So it's constantly comparing the state of the cluster to the state that you have declared in your Git repo. And if the cluster has drifted for any reason, it will reconcile the cluster back to the state that you expect. So this is really great to help you reduce cluster drift. So that's the high idea about GitOps. Just looking in a little bit more detail about what the workflow looks like on your particular Kubernetes cluster, uh, uh, we install for you an instance of Flux, the Flux CD GitOps operator. It's a CNCF project right now. It's one of the main GitOps operator that's in use today. And what happens is that this instance of Flux is configured to track your Git repo. And then when you, as a cluster admin or as an application developer, do a commit into the Git repo, and you may also build and push your images into a container registry, Flux will see the changes in this Git repo, and it will then pull down the changed manifest files, pull down the referenced uh, images, and then apply them through the Kubernetes API internally. What's interesting about this is that it's a pure pull model, and so it limits the need uh, for you to give access to folks in the normal push model that you would see. So it helps with also the security of your Kubernetes clusters. So what we're talking about today is some of the new capabilities that we have now for GitOps within Azure. Of course, when we released Azure Arc-enabled Kubernetes, which is currently in public preview, it includes the ability for you to use GitOps in all of your Arc connected clusters. What we're doing today is we're expanding the capability of GitOps to also work within AKS, Azure Kubernetes Service clusters that you may be using within Azure. So now what this means is that you can start using GitOps across not only your AKS clusters, but also your Azure Arc-enabled Kubernetes clusters, which means you can start managing the entirety of your Kubernetes estate from within Azure. And within AKS, the clusters are enabled as an AKS add-on. So it's very simple to enable GitOps within AKS. And again, we're going to be releasing this to private preview very soon. The second thing I want to show you is also we're adding some new authentication capabilities to GitOps within what we're now calling the Azure Kubernetes Configuration Management within Azure. You might think of that as Azure GitOps. And the various authentication scenarios that we enable are what we have enabled for the past year is the ability to authenticate with public repos and also private repos using SSH, where Flux actually generates the key pair. What we're enabling now is SSH, where you can bring your own private key if you want to use your own SSH keys, and also with SSH, if you can bring your own known host file. Say if you're using a private Git host and that some of the authentication is protected with a CA cert, then you can give us the known host file, and that will be put onto the pods, and you can authenticate with that as well. And finally, we are enabling HTTPS authentication with Basic Auth, and you can also set up the Azure Arc agents so that they can talk out through your outbound proxy as needed. So again, this is important because we're meeting you where you are, and for all the various authentication, different types of Git repos that you have, and the different types of authentication, you can now use Azure GitOps against your repos. So what I'd like to do in this demo is combine a few of these new capabilities and show you how to manage an AKS cluster from a self-hosted Git repo. And in particular, we're going to set up GitOps on an AKS cluster. That repo is going to be a Bitbucket repository. That's a private repo, Git host. And we're going to use SSH with a user-provided key. And we're also going to provide a user-provided known host so that we can authenticate the Bitbucket repo with Flux. So let me switch right now to the Azure portal really quickly. And here we are in the Azure portal, and I'm showing you we have several AKS services, Kubernetes services clusters, and we also have a couple of Azure Arc enabled clusters. I'm going to click really quickly into this one here, this demo AKS4. And what I want to show you is that for the private preview, for those of you who are familiar with Azure Kubernetes Service, what you can see now is that under settings, you have a GitOps option. And if you click that, then you can go in here to a page where you can set up GitOps, and you can also manage GitOps configurations. So I'm not going to set that up right now in the interest of time, and I'm going to go to this cluster right here and go down to GitOps and show you in this case, so you're not seeing that enable GitOps sign. So we've already enabled GitOps. The agent tree is already on this cluster. And now we can go in and we can start adding configurations. So I'm going to make a quick move over to the to Visual Studio Code, and I'm going to show you some of the clusters and some of the information you have on them, and also show you how to install a GitOps configuration. So let's take a look at the one that was AKS4, and this was the one that did not have GitOps installed yet. So what I want to do here is show you that the pods for the GitOps agents are actually installed into the kube system namespace. And you can see here that for this particular cluster, you don't see any config agent, and you don't see the GitOps manager pods running within that that cluster. So that's the one that I showed you did not have GitOps enabled. If I wanted to enable GitOps, I would use this command right here. I'm not going to do this now in the interest of time because it takes a few minutes. But basically, you can use the AZ AKS CLI command and use the enable add-ons method, and point it to the GitOps add-on. Give it your cluster name and the resource group, and then it will install GitOps on that AKS cluster. Of course, you can also do this through the UX if you want to. And you can also do all of this through the API as well, if you want to automate this sort of process. So let's go down now and switch to that cluster that I showed you that already has GitOps enabled. And if I do the same command, the get pods out of the kube system, you can see here that we have the config agent installed, and we also have the GitOps manager pod installed. The config agent is the agent that is tracking, it's within Azure, and it's tracking your commands to this cluster to install an instance of Flux on the cluster. So it's taking the commands that you give from Azure and applying them into the cluster. And then the GitOps manager is the agent within the cluster that actually manages the creation and the deletion and the update of the Flux pods within the cluster. So let's do one more. Let's look at the namespaces here. So one thing I wanted to level set here on the namespaces is that here we have the 4 standard namespaces that you'll find in an AKS cluster that you spin up. So what this means here is that even though we have the GitOps operators installed within the kube system namespace, we still haven't made what's called a source control configuration on this cluster. And the source control configuration is the instance of Flux that's going to be running to manage GitOps on the cluster. So let's take a look here. I'm going to use AZAKS to K8's configuration CLI to actually create on this cluster. And what I wanted to show you here is some of the new parameters that you can use now, both in the CLI is what I'm showing you here, but they're also available within the API. And I'll show you a sec in the UX as well. And one is HTTPS key and HTTPS user, where you can pass in the username and the key or token for that user and use HTTPS to authenticate against the Git repo. You can also pass in SSH known hosts, and this you can either pass in the known host content itself directly here, or give a reference to a local file that has the known host content. And the same thing for your SSH private key. If you have your own private key, you can pass this in through the CLI or through a local file that would be uploaded. So again, what we're doing here is we're going to be creating a new source control configuration on this cluster that has GitOps enabled. And what I'm going to do is I'm going to, again, use another command, which is AZ-K8s configuration create. I'm going to give it the repo URL here. You can see that the URL is a Bitbucket server. I'm going to give it the name of a non-host file, which is local on my machine here, a private key, and then some other configs for creating one of these GitOps configurations within this cluster. And so I'll get that running. And this tends to run quite quickly. There we go. So I'm going to just step back here to the UX for a second, click refresh, and here you can see that an instance of the source control configuration resource in Azure has already been created. And this source control configuration in Azure has the information about this particular instance that we're installing. So it's still installing, it's still in the pending state. And if we, one of the things I wanted to point out here at this point is just to show you that if you wanted to install from the UX, there is now a UX to do the same work from the UX, where you can give the name of the configuration, you can give a bunch of information, you can put in the URL of the repository, you can pick whether it's a private or public repository, you can pick between SSH, HTTPS, you can let Flux generate the SSH keys or paste in your own key or upload the key from a file. And if you want to use known hosts, you can also paste in the content or select from a local file. So just showing you that we have the complementary UX for this. Now, if I go back to our to the Visual Studio Code here and do get namespaces again. I just wanted to show you that there's a couple of namespaces that have shown up. One is this Flux Bitbucket. Flux Bitbucket is the one that has the instance of Flux in it. It's going to have the Flux and the Flux Helm operators in it. That Flux operator has been tracking that Git repo I mentioned about. And you see this other namespace here, which is called demo. Demo is a namespace that was created from the Kubernetes manifest in that Git repo. So it is showing that Flux has already just downloaded the manifest from that repo and applied them. So let's just take a look real quickly at the pods that are in the Flux Bitbucket namespace. And you can see we have Flux Bitbucket, which is the Flux pod. We have this Flux Helm operator as well, which manages Helm releases that you have, and Memcache, which is another one that's used in the processing. So let's take a look also in that demo namespace. And here you can see that the demo namespace is one that was created from that Bitbucket repo and is installed several different services within here, Redis, Podinfo, and Mongo. And you can see that one is actually in a state that we're going to have to go check out because that Helm chart is not configured correctly. So let me just go real quickly back to the portal and show you a couple things. One is I refresh here, and we can see that this is in an installed state. You can always go in here and get the message about this installation if there's any problems with it. But you can see that in this case, it was all successful. And if we go over here with an AKS and look at a couple of capabilities, one is that you can actually see here in the UX again, you can see all the different namespaces, demo and Flux Bitbucket showed up, and you can also see workloads in the UX as well. This is very, very handy. If I sort those by age, you can see the three that were laid down from the Git repo. So with that, that's our demo. And I'd like to thank you very much for joining us today and for watching the new capabilities we have with GitOps within Azure. Thank you.
So Jason's back. We've got a few links there for getting started.
Sure. Yeah, I'll quickly talk about the links that we have, and I hope you enjoyed the theater of the mind version of our GitOps demo for all of you D&D players out there.
Yeah.
We have a natural one on live demos and screen share, but hey, appreciate everybody hanging in with us. Yeah, so what we got again is some links to the Arc-enabled infrastructure that I mentioned, as well as a call out for trying Azure Arc-enabled data services. We have this Jumpstart repo. It's the fourth link down. The Jumpstart repo is an open source GitHub repository that has a number of scenarios implemented that allows you to see, managing Kubernetes across multiple cloud providers, as well as GitOps scenarios that go along with it. There are scripts in there which include, Terraform to provision a demo environment. And it's really awesome resource, tons and tons of scenarios there for you to kick the tires. As well, we have the technical documentation, which just links out to the Azure Arc documentation repo. And then much like Kubernetes AKS service, we have an Azure Arc learning path, which is in its infancy. Definitely go kick the tires and at least get some high level concepts there. And we're definitely interested in feedback in terms of that learning path.
Sure. Thank you. Thank you, Jason. Thank you, Chris. Much appreciated. I also posted a few links in the chat for those of you who want live links right now, and a copy of the slides are out on our site as well.